In this lesson, I'm going to demonstrate some of the advanced concepts in order to create, in addition to the random walk lesson that we did previously. Here, I'm going to show you and demonstrate other mathematical functions, such as the Lindenmayer system, also known as an L system, which is simply a string rewriting system that can be used to generate fractals with dimensions between 1 and 2. So this could be, you could draw, in fact, anything using this system. And it provides a very powerful way to construct fractals. It uses the L system to describe the behavior of plant cells, for example, and to model the growth processes of plant development. So since we're talking about plants, I'm going to demonstrate how to use a tree or create a tree in Python using the L system. So let's jump right to the code. So I'm going to go ahead and first quickly put a comment. So I'm going to say how to make a tree, or a lookalike tree in fact. And then we're going to use the fractals using the L system. And this was by, I'm going to put the name here so you can search. Great. So next, let me go ahead and do the import here quickly. So from turtle, import asterisk. I'm going to first set the angle of, let's see, the branches, the length of the branch that I would like for the tree, and then the depth of recursion. So first, get our variables in here. So I'm going to have t as the angle of branches. I'm going to say it's 22. And then our, let's say, d equals 16. And then n equals 4. So the first one is essentially the angle. We'll write the comments here. Branches. Then we have our length of branches. And next we have the maximum depth of recursion. Let me tab forward so we're looking good here. Alright, great. Next I'm going to do x equals, let's do the Lindenmayer system, right, or the L system. And that's just a formula that we use essentially. So it's f minus x, and then it's going to add another x to it, plus it's going to do the f, and then we have our brackets, and then the fx again, and finally it's going to subtract the x. And that's essentially, again, is the Lindenmayer. Next we do f equals f here, and then we stack it. We do our definitions. So def x n would essentially be a condition. So if n is greater than 0, go ahead and use the L and then the xn. Else, put a dot. And this dot would be, let's say, a node on the tree. So the size would be 16. And let's say it's going to be green in color. Our next definition would be for the f of n. And our condition is if n is greater than 0, we're going to do L and then parentheses f comma n. Our f is going to be capital here. Great. And our third definition here would be def of L, and this would be s comma n colon. And then I'm going to use my pen size, and this would be n times 2. So n times 2, and then for loop here for c in s. And I can put a condition here, right? So I can say something like, and I'll be building various elifs. So this is how it's going to move from one dot to the other and basically create these branches. So in this loop, I'm going to say if c equals minus, which essentially is the length of the, so it'll be LT times t, or in parentheses t. Then I'm going to say elif c equals, I'm going to add to it, so use the plus sign, and this would be RT and then T. In fact, tab, right? So we are consistent with our tabs. There we go. Here. All right, great. So let's go to our next elif. So this would be elif c equals x, and here this would essentially be x and then n minus 1 in parentheses. I'll do the tabs later on. Okay, so I'm just going to write it first. So next, my elif c equals f, and this would imply fn minus 1, and then fd, and then d in the parentheses. Let me scroll down here. Alright, so here's our elifs so far for the minus, plus, x, and f. Next, I'm going to do the elif for c equals, and here basically I'm going to append, right? So I'm going to use the append method with stack. So in order to do this so that it stacks up all these dots and branches on top of each other as it's building the tree. So if I don't use the stack and the append method and specify the positions, Python would not know where to go and where to stop and so on. So here I'm going to say stack append, and then my position, the heading, and then the n. I'm not done yet because I need to specify also the I and j, so which is I comma j, and then of course our h and p. And this is going to make sure that Python stacks. And once it's done, it's going to do a stack.pop. And I still need to close the bracket here. So I want to make sure once it stacks it and appends it, give my position, heading. All right, after the heading, I need another elif because that's going to happen afterwards. So I'm going to say elif c equals, and then close it right here. Great. So basically, it's essentially using this first elif. Let me go ahead and put a quotation here. So here we go. Better. Great. Get my indentation properly done. So once I told Python to stack, next I'm going to say pen up, then tell Python to go to the I and j position one more time, and then set h to my height, pen size one more time, set this to p, and then of course my pen down. Next I'm going to tell Python to do the elif c equals brackets, or in fact I think I'm done with my elif, so I don't need elif. I've already told Python so far to do the pen down here. Next I want to in fact begin again, so I want to tell Python to do a pen up and then go to, because it's going to continue this for loop, right? Otherwise it's just going to do this once and stop. So I'm going to tell it to go to a position of 0, comma, minus 200, and then do the pen down, set h, or to let's say 90, give it a color, so let's say it's brown, and then the next color would be of course our green, because we like our trees to be green. And finally the x and the n. Great. Alright, let's see if the L system has been designed properly. Let me go ahead and save it, and we're going to call it my fractals tree.py. Run it. Let's take a look. Line 15. What do we miss here? Of course, it says invalid syntax. So let me go ahead and in fact fix this tab or the indentation. So let's save it. Let's run it again. Let's scroll down. So it seems our code is so far so good. So since our code seems fine, let me go ahead and save it. Maybe I didn't save it, so let me go ahead and do a Control S, and let's do a Control B. Oh, perfect, there you go. So we have our Python canvas, and notice how these fractals using the L system is working, and how Python draws up and then creates, in fact, something that looks like a tree. It's going to keep building it till it finishes. So this way you can create, using the L system, or any other mathematical complex formulas in advanced graphics. So I hope this helps. Practice using this code. Obviously, you need to first understand the mathematical functions and formulas, and it'll take some time for you to apply those. But once you get the hang of the actual workings of Python, it becomes easier and you know how to fit in the code. Okay, so I hope this helps. Practice, and let's move to our next lesson.